Hello students, my name is Sumit Sagar Hota. I am a PMR PhD student at IIT Palakkad. Today we will discuss lecture 1 to lecture 5 of the subject Introduction to Airbreathing and Propulsion. So today we will discuss lecture 1 to lecture 5 by Professor Ashok Desai IIT Kanpur of the subject Introduction to Airbreathing and Propulsion. In this section we will solve some of the MCQs and some of the problems. Okay. It will be some 1 hour or 1.5 hour section. Okay, so you should go through all the lectures available in the NPTEL. So okay, so the first question. Okay, which of the following is not an aircraft propulsion system? Okay, so so okay, so this is very simple question. Yeah, just write down. Okay, so if you see reciprocating engine, piston engine, rocket engine, all these are the kind of aircraft system, but there is no high lift device. There is no such kinds of devices are there. So we know what exactly this high lift device means. Okay, this high lift device means it's used to increase lift produced. Okay, what does it mean? Or one example I can tell, the flaps in the aircraft wings, you know, flaps. So those flaps are the example of it. Okay, the kind of high lift devices. So okay, okay, so these flaps are used in okay. So let's go to the next one. So which of the following is not the type of an aircraft propulsion? Okay, so you know the name of this subject or is airbrathing and propulsion. This is a type of aircraft propulsion system. Non-airbrathing is also where, like in space, where there is no air. That also a kind of non-airbrathing systems, and rocket engines are also the type of aircraft propulsion system. But this Longerons is the not the kind of not the kind of aircraft propulsion. So what exactly these Longerons are? Longerons, okay. So it's a kind of structural element structural element of an aircraft. Okay, okay, what, how it helps in aircraft? It prevent bending of the aircraft. Okay. Okay. Also, this is a heavy. It can be defined as heavy structural member that run straight. Okay, it cannot bend. If it bends, then there is a kind of crash of the aircraft. Okay, so so next is which of the following is an advantage of the which of the following is an advantage of an piston prop engine. Okay, so piston prop engine always deals with the cheap and the low fuel consumption. Okay, so this is the case. It does not work on supersonic speed. It does not limited performance, or all these things are not the part of this. Okay, having very good performance and highest speed. It does not operate also very high speed. Okay, not the supersonic. It can operate in more or less subsonic. Okay, so the piston prop engine, this is cheap, low fuel consumption, but the this is actually very old kind of system and widely used in early 90s or those eras. These are used. But, and so that's the reason it suffer with what, from speed limits. Okay, these are some of the disadvantage. One disadvantage it is having. Okay, so let's go to the next one. Which of the following is part of turbine engine? Okay, it's a very simple question. Okay, compressor is a part of turbine engine. Okay, more specifically, so yeah, but if you see, the thing is, in this question some other options are also there. We should also go through what are these things correspondence to. Okay, okay, so, yeah, and okay, and what is a flap? Okay, so flap is the secondary control surface. Okay, what are other two things? Aileron, it helps in, these are all primary control surface. Okay, aileron and elevator. The aileron and elevator, these are all primary control surface of a aircraft. Okay, so aileron helps in rolling motion, to control the rolling motion of the aircraft, and elevator used to control the pitching motion of the aircraft. Okay, Let's go to the next one. A typical turbine engine consists of dash. Okay. So it's a very simple answer. The A is the option. Okay. It consists of a combustion chamber, a turbine, and a compressor. Okay. But if but instead of this, if the question changed to a uh, fighter aircraft, because in fighter aircraft we need um, high efficiency, there is one more additional chamber is there. We called it afterburning section. Okay. So for fighter aircrafts, combustion chamber plus turbine plus compressor plus afterburning, which reutilizes the hot product gases and it again divert it to the combustion chamber to increase the combustion efficiency. Okay. And for any turbine engine, or if you can write down commercial aircraft, okay, then only this much is the case. Okay. So okay, let's go to the next. Okay, so the next one. What is the function of compressor? It's very simple one, to increase the uh, pressure, okay, and temperature. Okay, it's very simple. Just quickly, just so if the pressure will increase and temperature will increase, because of increase in pressure there will be a chances of increase in temperature. So what? So if we increase pressure and temperature, then what it will be? There will be a what? Decrease in the velocity. Okay, so that's what we want. For the what? Okay, so yeah, for the turbine. Okay, so yeah, next question. What is the use of turbine? Okay, so that's the reverse of that. Okay, okay, so if you see, yeah, so it's actually used to generate the work to drive the shaft. Okay, so yeah, here the pressure is actually going to reduce, temperature is going to reduce, which in turn velocity is going to increase. Yeah. More specifically, if somebody asks, this is combustion products pressure is reduced. Okay, so this is the case. Okay, so let's go to the next. So which of the following is the correct? Okay, directly A is the answer. Okay, compressor consumes the work produced by the turbine. So now compressor produces work, compressor never produces work, so this is wrong. And compressor increases velocity of the flow. What we see here, because of compressor, what compressor do, increases the pressure, okay, and which in turn velocity is going to decrease, okay. So velocity is going to decrease, okay. So this is also wrong, okay. Lift is always same as weight, not weight, okay. uh, lift, okay, lift is a different thing, weight is different thing, okay. Lift and drag are different things, so lift is never be equal to weight, okay. So not a valid, not means it's actually, it's not always valid, because there is some other factors are there, like for example, how much lift is there is not same as how much drag is applied is on the aircraft, or there will be some other losses, like there will be some friction loss, all these losses are there. So whatever the lift of the aircraft never be equal to the weight of the aircraft, okay. There we need higher lift because of air friction and some other factors, okay. So that's also a wrong statement, okay. Okay, let's go to the next one. Okay, which of the following is a type of compressor? Okay, so this is a kind of tricky question, okay. Flap is obviously not a compressor. Oh, so these other two compressors are just a dummy. These are not actually exist. Incline, and there is no incline compressor or other compressor. There is only one compressor left, which is the centrifugal compressor, okay. These kinds of question also can be asked to confuse you, okay. So what is a centrifugal compressor? Uses centrifugal force to fling the air, okay. Okay, so the next question, uh, okay. So one diagram, and there is one diagram shown in the right side, okay. So what does this diagram means, okay. So you can see here one very good, okay, in so in some questions they are not going to show you this is the propeller or this is the piston, okay. In that they only show you this line diagram and then ask you what is this, okay. So here actually you can see one piston is there, okay. There exists one piston, and then there exists also one propeller, okay, in the in the aircraft engine, okay. It's obviously what piston prop engine, okay. So what is piston prop? What is piston prop engine? Okay. Is piston and propeller to generate useful work and thrust, okay. Okay, what are the disadvantage of it? It is actually heavy because of piston, and because of also piston produce noise, produces more noise, okay. Next one. Okay. Some in this question, if you can see one, I have to say, I have to just tell what kind of engine is this. Okay, here you can see one centrifugal compressor is there. Okay, there is this one centrifugal compressor, there is one combustion chamber, and then one turbine is there. Okay, then exhaust. Okay, okay, so here that it's not, there is no kind of pistons are not there, right? So it's not a piston engine. There is not, there is no piston and there is no propeller also. This is not a piston prop aircraft. Okay, okay, so now turbo means turbine is there, but there is no propeller here. Okay, it's also not a turboprop design. So there is only one left, that is the turbojet engine with centrifugal compressor. So in most of the question they are not going to tell this centrifugal compressor is existed or not. It's now little easy, but in the questions they only write down turbojet engine. Okay, so yeah, now it's easy, but if sometimes they're also not going to mention it. Okay, so answer is A. Okay, okay, so uh, so this is a turbojet engine. Okay, okay, so it consists of one combustion chamber, one turbine, one centrifugal compressor. Okay, okay, so yeah, so yeah, same. mm, Here one compressor is there, one combustion chamber is there, and one turbine is there. Okay, this is a kind of same thing. Okay, we just see turbojet engine. This is more very good. Is better question than the previous one, because here directly it mentioned the turbojet. Okay, so yeah. So what is, how this turbojet engine operates? This turbojet engine operates on, I think Aditya, you want to ask anything? Okay, so yeah, turbofan, turbofan, but there is no fan kind of structures are not there, right? So if there is turbine only exist means we just tell it as a turbojet. Okay, or more specifically typical turbojet. Okay, because there is no propeller as there are no respirating system, they didn't give. Turbo is there, but fan structure they didn't mention, so we can't tell that it's a turbo fan. Maybe in next I will show you this turbo fan also, how it looks like. Okay, so it actually operated by axial flow. More specifically, if you see, the flow is actually axial. Okay, here is the inlet and here is the exhaust, kind of axial flow. Okay, that's actually I'm about to write down. Okay, but this turbofan does not actually work on axial flow, because there are also some rotating parts, all these parts are there. Okay, rotating fan is there. Okay, so operated by axial flow. Okay, Okay, so it's actually now it's very simple. Okay, so you can see it's a kind of your, if you only see these parts, okay, this is your obviously what, your typical turbojet engine. Okay, and with the turbojet engine there is one what, propeller attached. Okay, okay, so propeller plus the turbojet engine means it's a kind of what, your turboprop engine. Okay, okay, the turboprop engine. Okay, okay. So yeah, okay, so yeah, so you can see now this is what Aditya actually told about this fan. Okay, so in this engine, if it's also axial flow, but before the inlet there is one fan exist. Okay, it's not completely the axial flow because there is some bypass air also can pass. Okay, so axial flow plus there exists a bypass system. Okay, then for the turbofan. Okay, and there is actually here one fan is there, right? Fan, and this is your complete turbojet engine. Okay, fan plus turbojet engine. Okay, so this is your what, turbofan. Okay, but because of this bypass system and with the axial flow, the the efficiency of turbofan is higher than the efficiency of the turbojet. Okay, so this can be asked as a question also. Okay, okay, so yeah, the next one. Okay, so which of the following method is used to exclusively in fluid mechanics? Okay, 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 this is a kind of confusing question. Okay, so because in fluid mechanics you can see all kinds of methods, Eulerian, Lagrangian, everything you see. Okay, but here the question asks something else. It actually wants to focus on one word like methodology exclusive. Okay, this word is very important. Okay, okay, okay. Exclusively in fluid mechanics, what does it mean? Okay, okay, so that means exclusively means for in general case, like general state of motion at various points. Okay, in fluid mechanics or fluid system. Okay, okay, this is the this is the definition of which system. This is the definition of Eulerian system. Okay, or Eulerian method. Okay, but in the other hand, Lagrangian method, deals with the motion of each particle. Okay, so your answer is A. So in general, Euler method we can tell. Okay. So yeah, next one. Okay. So what is the stagnation point? The stagnation point is the point in fluid mechanics where the velocity of the fluid at the point is 0. Okay. So what is the example also we can see? X, Y or Z, any point is equal to 0. Okay, this is your velocity. Okay, so your X, Y, Z is your coordinate axis. Okay, so the example will be fluid surface. Okay, the best example is the fluid surface of the object. Okay, okay, okay. So next is, what is model testing? Okay, okay. So okay, model testing means, always you remember, model testing means a kind of performance testing. Okay, so basically I'll tell in details what is this model testing means. Okay, okay, this is a process to study complex fluid dynamics. Okay, this is same as performance testing of test model or performance testing test model. So whatever I'm writing, each definition of model testing can be a question. Okay, so it's a kind of performance testing of test model after what can be a question after a standard scaling. Okay, so okay, you can write down here. Okay, so this we already know, models always smaller than the final design or the final prototype. Okay, but in some cases it can be also larger. But for example, for smaller objects we can actually make it a larger one to study in detail. But in fluid mechanics, in whatever question, it will be always more or less smaller in general. Okay, models are usually smaller, so we write down usually, not always. Okay, usually smaller than final design. Okay, so yeah, next one. When a fluid is subjected to resistance, it undergoes a volumetric change due to dash. Okay. 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 So cohesion, adhesion, strain. Okay. These are also one. Is not. They are not subjected to any resistance. Okay. Here one term resistance is there. Okay. So fluid is subjected to a resistance. Okay, when there is always remember, if there is a subjected to any resistance, means it's always some, either it will be a compression or expansion of the fluid. Okay, so the similar answer is compressibility here. Okay, okay. so yeah, so it's compressibility. Okay, so the compressibility is the measure of relative change in volume of a fluid. Okay, so this compressibility can be renamed in some other sense, like this compressibility also called, or more specific or more useful term of compressibility is isothermal compressibility. Okay, but it sounds different, right? Because we now seen previously that when there will be application of pressure, there will be chances of increase in temperature. Okay, but here where it's a kind of ideal situation of compressibility. Okay, so yeah, just in some cases they are actually going to write down in isothermal compressibility or something like that. You should know that, or just it's the same as the whatever the compressibility we have. Okay, so yeah, so here actually the pressure can increase but temperature is equal to constant. Okay, okay, yeah. So next one. Okay, the compressive flow is assumed to be dash. Okay, so there is a very good term here written, compressible, some compressible flow. Okay, there is one term written, what, isentropic. Okay, isentropic. Okay, this isentropic means reversible plus adiabatic. Okay, so reversible, when we want this any flow to be isentropic, we always assume this of reversible and adiabatic compressible flow. Okay, So yeah, so when this compressible flow can be your isentropic in ideal conditions, is a kind of ideal condition you can write down. Okay, and when this isentropic condition applies, it will be always reversible and adiabatic system. Okay, okay, but it can change in what? Fluid density, because it's compressible flow, but it can, that's the reason it can change the fluid density. Okay, so if it is can change fluid density, that means normal fluid system cannot solve, because in normal fluid system we assume the fluid to be what? Incompressible. Okay, so normal fluid mechanics cannot handle this, or Bernoulli equation cannot be applied here. We have to apply the gas dynamic equations. Okay, so it deals with gas dynamics. Okay, where Mach number, all these things are taken into considerations. Okay, okay. So the next one, the principle of fluid mechanics works on the utilization of gas. Okay, so why you are doing all this? Because it's actually, it's not about any kind of velocity. Okay, it's not about any kind of accelerating mass. Okay, does not, fluid mechanics does not account all these things. Okay, volume and work is actually kind of confusion. Okay, but volume also, there will be a expansion or there will be a compression of volume, due to which there will be a production of work. Okay, so volume also cannot be the primary of choice. Okay, we need to expand or we need to compress. Okay, so yeah, so that's the reason why the final choice is the work. Okay. Principle of fluid mechanics, utilization of useful work. Okay, utilization of the useful work. Okay, okay, so yeah, so the, okay, so the pressure variation of compressible fluid is maximum for which of the following kinds of process. Okay, okay, so see, there is different kinds of processes are there. One is adiabatic, quasi-static, isothermal. Okay, so okay, here here many things are we need to note. First, pressure variation. Okay, that means there will be a kind of, and pressure of the what? Compressible fluid. Okay, they are talking about compressible fluid. Pressure variation they want, and they want the maximum pressure. That means P pressure leads to P max. Okay, which of the following kinds of process? Okay, which of the following kinds of process they want? Okay, that means it will be a process. Okay, it's not a system, it's a process. Okay, okay, so okay, so okay, adiabatic is a not a process. Adiabatic is a system. Okay, and isothermal is also a system. Okay, but isothermal case, we can reach actually P leads to P max. Quasi-static process. In quasi-static process means there is a kind of reversible process, reversible and adiabatic. Okay, kind of your it's actually extremely slow and it's a reversible process. Okay, so but in that extremely slow process, there is very less chance, or there is no chance of increasing the pressure to P max. It's not possible. Okay, and in adiabatic process, because there is there will be heat transfer, all these things will be equal to zero. That means for the adiabatic process, if you apply first law of thermodynamics, your for the adiabatic process, your work will be only equal to your what, internal energy. Okay, 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 delta U. So there is no way it can be, the pressure can be maximized. Okay, so this is also not a choice. So yeah, isothermal can be a process. Okay, so actually we see this thing in previously. Okay, you can see the one term I just shown you, the isothermal compressibility, which measures the relative change in volume of the fluid. Okay, in that case we just see that pressure will increase and the with temperature remains constant. Okay, for the compressibility of the what that means here one thing here is absent, that didn't mention here. Okay, it can be applicable to the what, so one thing here didn't mention, can be applicable also to compressible fluid. Okay, this is very important statement. Okay, so this can be also asked. Okay, this isothermal compressibility, can it be applied to compressible fluid? Yeah, the answer will be true. Yes, it can be applied. Okay, so yes, so yeah, so our answer will be here. It will be a compressible fluid. Okay, so for the compressible fluid, okay, compressible fluid and P raised to P max. Okay, and P raised to P max okay, is only possible for temperature is equal to constant. Okay, or isothermal process. Okay, okay, so for a compressible fluid where this compressibility can be applied, that means yeah, our pressure can be reached to the maximum pressure. The only one condition, there will be temperature will remain constant. Okay, because in ideal cases when the pressure will increase, the temperature will going to increase. So here constant means two things. Here temperature constant means it means that temperature also increasing very slowly, or temperature is reached to temp T max. Okay, so here actually the case of T equal to T max for the compressible fluid. Okay, so that's the reason we're writing down is T equal to constant. Okay, because it already reaches what, maximum. Okay, so the next one, which among the following is an assumption for Hagen-Poiseuille equation? Okay, the Hagen-Poiseuille is a kind of flow. Okay, can search what kind of flow, all these things. Okay, but yeah, so it's kind of, so the thing is, what are the assumptions they want? Okay, so okay, So they only write down one option. Okay, it's obviously a laminar flow, but I just write down all the other conditions for the Hagen flow jelly flow. Okay, most common flow in the fluid mechanics. Okay, okay, Hagen Hagen flow jelly flow. Okay, yes. How I can show you the one example how it looks like. Okay, it basically means the laminar flow through a long cylinder. Okay, of constant cross section. Okay, so the velocity profile looks like this. Okay, here it will be your Bmax. This is your R, Z, and R direction. Okay, this will be your total length of the cylinder. So let it be capital R. Okay, so one relation also just remember. So Vz of R is equal to Vz not at R equal to or 0. Okay, into 1 minus small r square by capital R square. Okay, this is the velocity profile. Okay, equation of the velocity profile for the Hagen-Poiseuille flow. Okay, there are other things you just also search and learn about Hagen-Poiseuille flow. Okay, so the some of the other assumptions are like it's incompressible, laminar, Newtonian fluid flow in a pipe. Okay, so okay, so yeah, so let's go to the next one. So which of the following is a formula for the friction factor of circular pipes? Okay, okay, more specifically this friction factor first of all invented by Moody. Okay, and it termed as Moody friction factor. Okay, so yeah, so termed as So this F is equal to 64 by RE. This is a kind of empirical formula. He just done some experiment. From the experiment he just find out this relation. Okay, this is not necessarily, this is the only friction factor available. There is many scientists given different friction factor, but more specifically this friction factor are used especially for the laminar flows. Okay, more or less this friction factor gives you correct result if the flow is laminar. For turbulent flow this won't apply, it cannot be applied. And also this is applicable for circular pipe flow. Okay, it can only be applied for the circular pipe flow. Okay, and your Reynolds number is less than or equal to 2100 or laminar flow. Okay, so let's go to the next one. Which of the following is the mathematical technique used to predict the physical parameters? Okay, okay, this is a kind of mathematical technique to predict what the physical parameters, like what your like pressure, temperature, all these parameters are there. Okay, so it's used to predict the physical parameters. Okay, so a very simple thing, it's a so what does this physical parameter means? Okay, so physical parameter means parameters that influence fluid flow. Example will be your what? Maybe you can give an example like velocity. Velocity of the fluid is also a important parameter. Okay, velocity, pressure, density, etc. Okay, so yeah, so the analysis is not obviously, it's not a temperature analysis, because velocity cannot be done through temperature analysis. It's not only a pressure analysis also. Okay, obviously there is no role of combustion here. Okay, it's not also a combustion analysis, because in the turbine and compressor also this technique can be applied, not only in the combustion chamber. Okay, so only one thing left, that is the dimensional analysis. Okay, so the answer, okay, so what does this dimensional analysis deals with? It is based on the fundamental units like m for mass, l for length, t for time, and theta for the temperature in Kelvin. Okay, mass, length, time, temperature. Okay, so like for the, if we can give some example like velocity, we obviously know velocity is meter per second. Okay, okay, v is equal to s by t, that means it will be what, length will be there and t is your time is there, so lt inverse, okay, is your dimensional formula of the velocity. Okay, similarly if you can take pressure is your P is equal to F by A. Okay, and what is A? F is equal to mass into acceleration divided by area. Mass is your M, and what is A? A is your B by T. What is B? LT inverse. Again one more it will come, so M L T minus 2 divided by area is your what? Length. Okay, length square. Okay, divided by length square. So it will be what? M L minus 1 T minus 2. Okay, similarly density also we can find out. Density is what? dB. Density is equal to mass by volume. Mass is your obviously M. Volume is what? Is your length cube. Okay, or meter cube, you can write down the unit. Okay, so ml minus 3. Okay, so yeah, so these are some of the examples you can see. Okay, so the next question is, which among the following have the same forces acting on them? Okay, so this question little confusing. Acting on them means what? Them means sometimes like this question can be asked, say confusing, not complete question, incomplete question kind of. It's there. Okay, acting on them means it's the fluid particles. Okay, so now what they are telling, same forces. Okay, so it's a kind of similarity question. Okay, so if the same forces will be applied, that means there is not a geometric similarity, there is no geometrical conditions are applied, there is no conditions are also there, not a conditional. Okay, there is not kind of any kind of kinematic study or kind of your acceleration on all these things, nothing is there. Okay, so it's not a kinematic. Okay, so there is only one thing left, that is the dynamic similarity. Okay, so dynamic similarity. Okay, what is the definition of a dynamic similarity? Is the ratio of all forces acting or acting on boundary surface are constant. Okay, this is the definition of dynamic similarity. Okay, also one more way you can define, actually, same force acting on each fluid particles. Okay, 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 now let's come to the next one. Okay, so this question is, if a okay, one question here actually for this section you can solve. So if a piston cylinder with a cross sectional size of 0.01 meter square is resting on the stops, what should the water pressure be lift the piston with an outside pressure of 100 kilopascal? Okay. Okay, so here actually one more thing given, that is mass of the piston is already given 100 kg. Okay, so let's solve it. I'll write down this. So here area is given, A equal to 0.01 meter square. P naught is the initial pressure. Okay, is the piston with an outside pressure or outlet outside pressure is for PO. You can write down. Okay, is 100 into 10 to the power 3 Pascal is equal to 10 to the power 5 Pascal. Okay, so what we need, okay, if a piston is there, so what should the water pressure? Okay, we need the water pressure. So PW we want. Okay, okay, so PW we want. So yeah, let's go to the solution. So you know very well that this there is here's the written piston cylinder with cross section, this is resting on the stop. Okay, that means there is one piston cylinder arrangement is there. Okay, and it's resting on the stop. Okay, let it be here one. Okay, okay, here it will be your, this is your PW, this is the water pressure. Okay, so they are telling that the lift the piston with an outside pressure of this. Okay, on outside pressure is applied. Okay, okay, so P, okay, just let it be, this is the center of gravity of this system. Okay, or the piston. Okay, this will be your piston. So this force PW is applied here. Okay, this is your water. Okay, okay, and there is two forces are applied here. One is here, what, first is here, what, the P naught. Okay, is also going to apply, and one more, there will be the weight of the piston. Okay, maybe, which will be what, which will be the MPZ by the area of the piston. Okay, okay, so just let's balance the forces. Okay, so the PW is equal to P naught plus mpg by A. Okay, so P naught is your 10 to the power 5 plus 100 into 9.81 by area is 0.01. Okay, to solve it, will get 198 into 10 to the power 3 Pascal is equal to 198 kilopascal. Okay, so answer is your C. Okay, this is the answer. Let's go to the next question. Which of the following is the standard fixed point of thermometry? Okay, this is a very good question. Okay, and this reveals the most important parameter in a fluid mechanics phenomenon. Okay, so there is this question actually having the answer. Okay, first they are telling standard. Okay, standard means it's a kind of, in general, kind of system. Okay, fixed point, fixed point also one next hint they are giving. That means it's a kind of point. Okay, or a particular, it's a kind of what I can tell, means it's a kind of particular parameter which is having some particular or a particular uh, in a kind of thermodynamics. Thermometry means thermodynamics. It's a kind of in any particular point of any kind of fluid which is having a particular meaning. Okay, so like steam point is there. Okay, steam point is for the water, then ice point is there, triple point of water. All these are for the water in different states. Okay, so but the thing is, steam point is only for the vapor state of water, ice point is for the solid state of the water. Okay, so it is not it's not a it's a fixed point, but it's not a standard fixed point for all the kind of system. Okay, so for any kind of system, for any kind of state of water, only one point which will be applicable is the what, the triple point of water. Okay, so this is the standard fixed point of thermometry of water. Okay, called as triple point. Okay, standard fixed point of thermometry of water. Okay, so it's important. Okay, so yeah, so this is answer. Here one very good confusion will be, you can just write down all of the mentioned. Okay, most of the people will choose this all of the mentioned as the correct, because it's a fixed point and all three are the fixed point. Okay, if you ignore the standard word is very important here. The standard quantity, it's very important. Okay, if you ignore, then you just go for the answer D, and this is wrong, which is wrong. Okay, okay. Sorry, answer B. Okay, next one, which of the following gives the mechanical efficiency of the engine? Okay, mechanical efficiency very always, you know, the output by input is always the efficiency, is the formula of efficiency. Okay, so here a BP and IP are the, BP means the brake power and IP is the indicated power. Indicated power is always the input power, brake power is always the output power. Okay, Brake power by indicated power. Okay. Okay, we have one more problem. So this question is a refrigerator with a 2 kilowatt motor for powering the compressor gives 6000 kilojoule of cooling to the refrigerated space during 30 minutes of operation in a thermally insulated kitchen. Calculate the change in internal energy of the kitchen if the condenser coil behind the refrigerator rejects 8000 kilojoule of heat to the kitchen over the same time period. Okay, so this is the question. So just write down what are the things given. Okay, so in the question it's written here thermally insulated kitchen. That means the change in the heat energy is 0. 0. Okay, since insulated. Okay, next. So they are telling a refrigerator with 2 kilowatt motor for powering the compressor. Okay, for powering the compressor. Okay, that means the work done on the system. Okay, is electrical work done. Okay, so delta W, and what is your work done on the system? Work done on the system is always negative. Okay, so minus 2 kilowatt work done for how much time? 30 minutes. 2 kilowatt motor working for 30 minutes. Just convert it into second. Okay, so kilowatt is your kilojoule per second. So second get cancelled. So the unit will be what? In kilojoule. Okay, so and it's in negative, which is equal to minus 3600 kilojoule. Okay, so we have delta W. Okay, so let's apply the, because we need to find out the change in the internal energy of the kitchen or of the system. Okay, so kitchen is our system. So by first law of thermodynamics, okay, so delta U of system is equal to del U del Q of system minus del W of the system. Okay, we just remove it. Okay, okay, due to electrical appliances. Okay, so yeah, so because it's an insulated system, so your delta Q will be what? 0. Okay, and it should be noted that you here if there is a negative sign, just put the negative sign. Don't ignore that. If there will be one on the system again, you think okay, one negative sign already there, we don't put again the negative sign. Okay, that's wrong. Sign will automatically come. Okay, so 3600 kilojoule. So two negatives get cancelled. So delta U of Kcn will be 3600 kilojoule. Okay. So the answer is A. Okay. Okay. So next question. The heat flow into a system is dash and heat flow out of the system is dash. It's a kind of sign convention they want. Okay. So if it is a system, this is your Q in, this is your Q out. Okay. So when there will be heat input on the system, okay, then it will be positive. Okay. And heat output from the system or heat rejected is always negative. Okay. Okay. So similarly, if in place of work will be there, if I'll write down like this, work done on the system is always negative, work done by the system is always positive. Okay. System. Okay. This is the sign convention in thermodynamics, any thermodynamic system. Okay. Okay. And one more thing you also note, so heat always flows heat also, if you can relate with electrical energy, electrical engineering or potential. Okay. Potential flow from high temperature, okay, or high energy, okay, or high energy to low temperature or low energy system. Okay. Okay, this is the one thing you should note. Okay. The next question. In which of the following systems does mass transfer occur across the system boundary? Okay. You should note that it written that the mass transfer, first clue is the mass transfer occurs, means it should occur. That means there will be a mass transfer across, means across the what? Across the system boundary. In the system boundary, there will be a mass transfer occurrence is there. Okay. That means that we should know first of all what are the type of systems are there. Okay, there is three types, it's noted here. One is your open system, one is your closed system, one is your isolated system. Okay, okay, okay. So 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 first of all, we'll just note down what are the type of systems. Like uh, this is a kind of system. Okay, both, and this is one kind of system. Okay, this is one more system. Okay, so the system in which the heat can transfer in and out, okay, of the system. Okay, in and out. Okay, and your mass can come in and come out. Then this is called your open system. Okay, similarly, if there will be a transfer of heat in and out of the system, but there does not exist no m transfer. Okay, then it will be a closed system. Okay, this is your closed system. Okay, okay. If there will be no mass transfer, okay, and the system is what, adiabatic, there will be what, no heat transfer. Okay, that means m and q. If there won't be anything, then it will be a what, isolated okay, isolated system. Okay. So for this question, it returns mass transfer occur across the system boundary. Okay, okay. So it's a what, so it's a what, open system. Okay, but here in the because you see in the only in open system there is a permission of only a mass transfer. Okay, so answer is C. Okay, oh yeah, so let's go to the next one. Okay, just one more problem. A cylinder piston contains 1 kg methane gas at 100 kilopascal at 20 degrees Celsius. The gas is compressed reversibly to a pressure of 800 kilopascal. What is the work required if the pressure is isothermal? Okay. Sorry, if the process is isothermal. Okay. So let's write down what are the things given. So it's written isothermal process. That means your temperature is constant. Okay, that means or dt or change in temperature is equal to what? 0. Okay, this temperature is constant. So what will be your internal energy du or change in internal energy du is mcb dt. So it will be what? 0. Okay, so du is 0. That means or u1 is equal to u2. Okay, so that means if we apply first law of thermodynamics, W from 1 to 2 is equal to Q from 1 to 2. Okay, so but for the isothermal process we know this uh, the work done will be what? Sorry, this Q1 to 2 will having one formula minus mRT ln P2 by P1. Okay, this derivation you just go through. Okay, how this came into ln P2 by P1. Okay, so this is actually for isothermal process. You should always remember the work done formula is this: W12 equal to Q12 is equal to minus mRT ln P2 by P1. Okay, and why this negative sign? The negative sign for compression. Okay, yeah. So let's just substitute all these values and find out. So here one more things we just get. Okay, so R means here R for the methane, because methane is the 1 kg methane is written. So the R for the methane we need to find out. This should be given in the question. Okay, 0.51835, but try to remember if you can. Methane, ethane, air. So all this, for air 0.287. So all these values you should remember. Okay, so here temperature is here. Always convert it all things into Kelvin. So 20 degrees Celsius and 100 kilopascal given. So 20 plus 273, which is your 293 Kelvin. Mass given. Okay, so mass is 1 kg given. Okay, and P1 given 100 kilopascal, and P2 also given 800 kilopascal. Okay, so everything given in the question, just substitute. If you know only this formula minus mRT ln P2 by P1, then only you can answer this question. Okay, okay, so that's the thing. So just substitute and find out. Your minus 1 into R 0.51835 into T will be your 293. Okay, into ln P2 by P1. P2 is your 800 by 100. Okay, so if you solve all this thing, you will get W12 will be your minus 316 kilojoule. Okay, this is your answer. So answer is B. Okay, okay, and negative sign for the compression work. Okay, or you can write on work done on the system. Okay, okay, so that's the thing. Okay, let's go to the next last question. Okay, so the entropy of an isolated system can never. Okay, okay, so this what is the best example of a isolated system is our earth. We can tell, yeah, our earth is a isolated system. Okay, because outside the earth there will be completely, there will be no uh, there is no medium or nothing is available. Okay, and so, but if we consider, because but there will be a outside, from outside heat energy is transferring from sun. Okay, but if we consider earth is the only system, outside we don't care what's going on, or how out from outside what how everything is going, only earth is the system. If we can tell the energy inside the earth, okay, if we tell that as the system, so then this is the energy is only going to rise. Okay, the heat energy is only going to rise. There is no chances of decrease in heat energy. Okay, because from outside also there is chances of heat energy addition. Okay, so but it's actually at the end result will be the overall system's entropy always going to what rise. Okay, there is no decrement in the entropy of the system. Okay, so for that means for a kind of isolated system there will be only always chances of what increase in entropy. Okay, and if it is the entropy is always rising, then that means the process is also not reversible process. Okay, it's always treated as a irreversible process. Okay, so just club together all these things. So it can so the entropy of the isolated system cannot decrease. Okay, so always increase means it's a irreversible process, and most of the practical phenomena are like are irreversible. Okay, for example, somebody can also argue that no, the entropy of the system is always remain constant. Okay, this statement is also a true statement. Okay, it's not always increase also, sometimes it remains constant, whatever the input heat energy and whatever the output energy remains constant. Okay, and this is actually nearly impossible because most of the energy are absorbed and very less will actually go out. In some cases maybe there will be a chances. Okay, or more specifically the ideal condition, then the process will be reversible. Okay, so the entropy of of an isolated system remains constant. That means what we see the definition of a isolated system, that if there will be there is no mass and no heat transfer, but there will be the here actually the thing is here the change actually matters. Okay, if there will be mass transfer, that there will be it will be it should be negligible, that should be heat transfer, then it should be negligible. Okay, so then only the system is treated as a isolated system. Okay, as compared to the system, the heat and mass actually matters. Okay, if there is a 1 kg system, if there will be 0.5 kg will transfer, then there will be obviously a mass transfer there. Okay, then there will be a what open system. Okay, so like that we can actually assume the open system and isolated system. Okay, so with this we just end the section. You can see this recording in my YouTube channel. This is my name in YouTube, it's there. You can just check the in the playlist. You can just, if you didn't skip anything, you can just see it. You can have notes on and all these things. Okay, thank you very much for attending the section. We meet next week 6 to 8, and for the next week sections, live discussion section. Thank you very much. Have a nice day. Good night. Okay, bye.